Hello my dear students, this is Akash SD and welcome to the SD physics classes. Hope so you all are doing really great. So student, in this video we are going to solve the question from the chapter Dual Nature of Radiation and Matter, and the question based upon proton, deuteron and alpha particle moving in a uniform magnetic field is very important. I hope so you know somewhat basics when the charged particle is moving in a magnetic field. Three kind of situation used to be there. The charged particle may move in a straight line when the velocity is along the direction of the magnetic field. That means maybe theta 0 degree or opposite to the direction of the magnetic field when theta is 180 degree. In second situation, the charged particle will move in a circular path when the velocity is perpendicular to the magnetic field. Okay, and in third situation, the charged particle will follow the helical path when the angle between velocity and the magnetic field is not 0, not 180 and not 90. In this situation, which kind of path is there? What I told you, helical path is there. Okay, so here if you will see the question, in this question itself they have told you which kind of path is there, circular path is there. That means the velocity is perpendicular to the magnetic field. Okay, so let's go through the question, students. The question is a proton, deuteron and what is that, alpha particle enter in uniform magnetic field perpendicularly. That means theta how much? 90 degree. Angle between velocity and magnetic field how much? That is 90 degree. Okay, after that calculate the ratio of their radii of circular path for the four situations are there. Same speed, same momentum, same kinetic energy and same potential. Any of the thing they may ask in an exam. Okay students, so the things is very clear. The thing is what? The charged particle will follow which path? It will follow the circular path. So what will happen that here? Let's take the particle is moving in a which path? Okay, I have taken anti-clockwise. Okay, so velocity will be in this direction. This is the velocity. Okay, this is the velocity. Now students, what will happen that, as you know, magnetic field in which direction? Inside. So first we should know the force formula in a vector form that will act on the charged particle. Formula is what? V cross B. Okay, this formula will give the direction of the magnetic field. We have to curl our fingers of right hand from where to where? From V to B for the positive charge particle. What will happen that here? V this side, B inside. That means when I will curl our finger from V to B, thumb is going this direction, downward. That means student, downward direction is what? This downward direction force will act. What will act? This is the direction of the force. And this force will act as a what? This magnetic force is there. This magnetic force. This magnetic force only is acting as a centripetal force. Okay. And please make sure that if in case the charged particle is negative, then you know what will happen. The force will act in upward direction and it will follow this kind of path will be there. Like this, like this, like this. Positive charge particle, this one, anti-clockwise. Negative charge particle, like this. Okay. So remember that here. Now students, what will happen that here? After that, if we talk about the magnitude, so magnitude of force, that means mod of F, or you can write just F. It is given here QVB sine theta. And theta how much here? Velocity along x direction, magnetic field along negative z direction. How much angle? 90 degree. Okay. So we can write here anyhow it will come QVB because sine 91. Now again students, next thing. This magnetic force, what I am telling you, this FM, this magnetic force is acting as a which force? Centripetal force. Okay, so we can tell here magnetic force formula. What is the formula? As we know, QVB is equal to centripetal force. What is there? mv square, and let's take a radius of this circular path is r. Okay, so we can tell after solving both the sides 1v will cancel. This v and this v cancel. So we can write here r equal to students mv by bq. What is coming? R equal to mv by bq. Okay, this is one formula. Okay, after that students, again what is there? What is mv? Mv is called momentum, and you know one relation used to be there, k equal to p square by 2m. Okay, in 11th we have seen. What is p? P is momentum. Even here itself you can write here what I am telling you. See, here itself you can write here, see, P by BQ. What is P? P is the momentum. Now from here P will come what? The P will come here root 2 km. So root 2 km by BQ. Okay, this is in terms of kinetic energy. Now first one in terms of we can tell speed and momentum. Next one in terms of kinetic energy. What is K? K is the kinetic energy. Third one students here, if I talk about next one, so what we can write here, see, R equal to root K is given here Q into V. Q into V by BQ. Okay, students. So when you will simplify this, what this will come here? 1 by B, and here students it will come root 2V. Correct? One more is there. See, M is left. M is left. So it will come here root 2V M by Q. Kindly check it out. This is clear. 1 by B. In numerator root Q, in denominator Q. So anyhow in denominator root Q will come. Yes. So students, this is the third one. Now, so how many we have to remember right here? We have to remember the 3 one. First one, this is the second one, and this is the third one. Okay. This ratio, what to tell, this radius, you should remember that here. Okay, students. Next one here, they are talking about the proton, deuteron and alpha particle. Okay, so for that students, we should know one table actually. So to deal with this kind of question, you have to know this table related to the mass and charge here. Okay, students. So here I have taken, let's take here what a proton is there. Okay, and here what is there? Deuteron is there, and here what is there? Alpha particle is there. Alpha particle. Okay, this table. Now students, if I talk about here the mass. So if the proton mass is M, what will happen? This deuteron mass will be 2M, and this alpha particle mass will be 4M. Okay. If I talk charge, if I talk about the charge, so here if this is E, this is also E, here it will be 2E. Okay. So this mass and charge values you should remember relatively. Okay, students. So now what we are going to see? First one, we are going to see the same speed. What is there? We are going to see the same speed. First one, same speed. So what is there for first one? What is constant? V is constant. V is constant. So we know that. See, we know that R equal to mv by dq. Okay. And students, what is constant here? Speed is constant. So speed is constant and uniform magnetic field is there. That means what is constant? B is constant. Okay. So as speed and B is constant, we can tell R is directly proportional to m by q. Now, check out here. R is directly proportional to what? M by Q, because V and B is a constant. Now, students, hence, if I write here, this one, proton, deuteron, alpha particle ratio. Okay. So, first we'll write for the proton here. See, M is to deuteron, 2M is to alpha particle, 4M. Okay. Now, next one for charge. What is this? This is E. This is E. This is how much? 2E. Okay. Now what will happen? M by E all will cancel out. So what we can let us see? 1 is to 2 is to 2. So what answer is coming here? Proton, deuteron and alpha particle, when their speed is constant, the ratio of their radii will be how much here? 1 is to 2 is to 2, because 4 by 2 will become anyhow 2. M by E will cancel out here. Okay, students, great. Now after that, if we go for the second one. In second one, if you will check it out, what is constant? Momentum is constant. What is constant? Momentum. So what we can write here? This P is constant. P is constant. If they are asking, momentum is constant. Then again, see, we will use this formula. We know that R equal to P by BQ. P by BQ. Okay, because velocity will adjust in such a way so that M into V, this project should be constant. Okay, so as students, P is constant, B is constant, that means we can tell here, see, R is inversely proportional to Q. What is that? R is inversely proportional to Q. Hence, students, we can write here, see, proton, deuteron, alpha particle. What this will become here? Charge ratio we have to see. So see here, proton means 1 by E, deuteron means 1 by E, and here alpha particle means how much? 2E. Okay. So again, E will cancel out here. 1 is to 1 is to 1 by 2. Now what I will do here, students, see, I will just multiply here into 2, so that it should come in a regular form of the ratio. So multiply with the 2, what this will become here? 2 is to 2 is to 1. Okay, so this is the answer. So you can see very well, second situation, when the momentum is constant, the ratio of the radii how much here? 2 is to 2 is to 1. That means here what will happen? Deuteron and alpha particle will have the same radii. But here in this situation, what will happen? Proton and deuteron will have the same radii. Okay. Now students, after that we are going to move for the next one here. Okay, third one. Third one, what is there? if you see the question, let's go to the question one time. Now, in third one, they are telling same kinetic energy, and next one we have to see same potential. So for same kinetic energy, which formula we have to use? This formula we have to use for the same kinetic energy. Okay. So I hope so you remember the formula. What is the formula? R equal to root 2 km by bq. This is the formula. Okay. And again, I'm telling you what is constant now. Third one, this kinetic energy is constant. Okay, as they told. So what we can write here, see, R as the K is constant, 2 is constant, and B is also constant. That means what we can write here? R is directly proportional to root M by Q. Correct now? Root M by Q. This is this. Root M by Q. Is it? So now again, students, if we write here the ratio, so see here this ratio. Proton, no, deuteron, and alpha particle. So again, let's write for the mass first. So what is there? M, 2m, here 4m. Now like this here. Now after that, charge, only Q is there. That means again here students see E, here E, and here how much? 2E. Correct? Then what will happen that students here? Root M by E, from all will cancel out here. So what this will come here? 1 is 2. When root M by E will over, it will go here root 2 is 2. Here also again what will happen that students see root M by E will go, but root 4 will become what? 2. So 2 by 2 will become what? 1. So here the answer is coming here 1 is to root 2 is to 1. That means here you can see very well students, proton and alpha particle will have the same radii. Okay, and after that we are going to see for the next one. Next one, fourth one. In fourth one, what they are telling here? In fourth one they are telling students what is constant? Potential is constant. That means again we'll use it here. We know that R equal to 1 by B root 2 Vm by Q. Correct? Now already we have done this here. Now students, again what is constant now? Now V is constant and B is also constant, and this 2 V2 B is constant. That means we can write here R is directly proportional to now root M by Q. What is this? Now this ratio is coming here. Okay. Hence, if I write here proton, deuteron, and alpha particle. Again, let's write here the mass ratio. Root M, root 2M, root 4M. No? Like this we have written. Now we have to write for the charge also. For charge, what is there? Students, see, anyhow, this is the root E here, root E, and here how much there? Root 2 is there. Okay, you can write overall root also, no problem is there. Okay, now what will happen that students? Now root M by root E will cancel out here. So what this will come here? 1 is to root M by root E cancel. That means here root 2, and what will come here? Again now you see root M by root E will cancel out, but here root 4 means 2. 2 by root 2, what will come? Again you think 2 by root 2. 2 by root 2 will come students here root 2 here. Correct? 2 by root 2, what is there? Root 2. So students, here you can see what is there. This deuteron and alpha particle will have the same radii. Okay, so here students, you can see that here according to the question they have asked what? Same speed, same momentum, same kinetic energy, and same potential. These 4 cases I have taken. Okay, and for the when the speed is constant, this answer 1 is to 2 is to 2. When momentum is constant, this answer 2 is to 2 is to 1. And after that, when this kinetic energy is constant, answer is 1 is to root 2 is to 1. And when what is constant? This is the potential, V potential is constant, accelerated to the same potential. Then what is the answer? 1 is to root 2 is to root 2. Okay students, I hope so you have understood very well. Keep studying, keep growing. Take care.